So in this video, we're going to be looking at Jacobi Iteration Method, and we're going to be considering this question to explain this concept in details. Now, this question says, solve the system of equation by Jacobi's Iteration Method using the initial guess x naught equals y naught equals z naught equals 0. And you're given this system of equation 40x plus 2y minus 4z equals 34. That's equation 1. 6x plus 40y minus 2z equals negative 36. That's equation 2. 4x minus 6y plus 40z equals 50. That's equation 3. Now, in utilizing the Jacobi's iteration method, the first thing you need to keep in mind is the coefficient of x in equation 1 must be greater than the sum of the coefficient of y and z in that same equation. Similarly, the coefficient of y in equation 2 must be greater than the sum of the coefficient of x and z in equation 2. And finally, the coefficient of z in equation 3 must be greater than the sum of the coefficient of x and y in that same equation. Now, let's verify this and see. In equation 1, the coefficient of x is 40. Now, let's add up the coefficient of y and z. Mind you, you are not including the negative sign when adding up. Just pick only the magnitudes and sum up. Now, the coefficient of y is 2. The coefficient of z is 4. We are omitting negative sign now. So you have 2 plus 4, which gives us 6. Obviously, 40 is greater than what? 6. Similarly, the coefficient of y in equation 2 is 40. So now let's add up the coefficient of x and z in that equation. Coefficient of x is 6. That of z is 2. Now we are still neglecting the negative sign. So 6 plus 2, that gives us 8. Obviously, 40 is greater than 8. And finally, the coefficient of z in equation 3 is 40. Now let's add up the coefficient of x and y in equation 3 and see. So we have 4 plus 6, which is 10. And obviously, 40 is greater than 10. So which means the first condition has been satisfied. Okay, the coefficient of x in equation 1 must be greater than the sum of the coefficient of y and z. And the coefficient of y in equation 2 must be greater than the sum of the coefficient of x and z. And finally, the coefficient of z in equation 3 must be greater than the sum of the coefficient of x and y. Now, having achieved this, the next thing you do is simply make x the subject of the formula in equation 1 and make y the subject of the formula in equation 2 and make z the subject of the formula in equation 3. Then you can now apply your given initial guess. Okay, so from 1, we simply make x subject. If you make x subject, you're going to have x equal to, now I have 34 here, so we pull down your 34. This is now going to be 34. If I send plus 2y over here, it becomes negative 2y. So 34 minus 2y. Similarly, if I send negative 4z over here, it becomes positive plus 4z. Now, the whole of this is supposed to divide by the coefficient of x, which is 40. So let's simply say multiply by 1 all over 40. Literally the same thing. So you can call this equation 4. Next step, you make y the subject of the formula in equation 2. So doing that, you're going to have y to be equal to, so I have here negative 36, so minus 36. Okay, if I send positive 6x over here, it becomes negative. So I have minus 6x. Similarly, if I send negative 2z over here, it becomes positive. So I have plus 2z. Okay, now the whole of this is supposed to divide 40, which is the coefficient of y. So simply multiply that by 1 all over 40, and you'll have this. So this is going to be equation 5. And finally, you make z subject of the formula in equation 3. So z is going to be equal to, again, of course, if we divide by the coefficient of z, I'll still have 1 all over 40. Now multiplying through by, if okay, put down first your constants here, you have 50. Okay, so if I send positive 4x over here, it becomes negative 4x. And if I send negative 6y over here, it becomes positive 6y. So call this equation 6. So I have these three equations. Now we can simply apply our initial guess. Now, just keeping in mind, if you're not given an initial guess, like in this question, you were told, take the initial guesses to be x naught equals y naught equals z naught equals 0. That simply means x naught is 0, y naught is 0, and z naught is 0. But if you're not given this condition, always keep in mind that you're going to be always making these initial guesses, and you're going to be saying that x naught is always going to be 0, y naught is always going to be 0, and c naught and z naught is also going to be 0 for the initial guess. All right, so applying your initial guess now. Okay, so when x naught equals 0, y naught equals 0, and z naught equals 0, so you can now do your first iteration. So you apply the initial guess and carry out your first iteration. So you carry out the first iteration, and for the first iteration, don't forget we said x naught equals 0, y naught equals 0, and z naught equals 0. So that simply means for the first iteration, in place of x, x now becomes x1. So this is simply going to be x1, and this is going to be equal to, anywhere you see y in this equation 4, and anywhere you see z in equation 4, you simply put in the initial guess to be equal to 0. So y here is y naught, and z here is simply z naught. So that helps us to find x1, which is the first iteration. So x1 is going to be equal to, remember, I have 1 all over 40 there. So you have 1 divides 40, multiplying through now by, I have there 34. So you put it down, 34 minus 2y, that's going to be minus 2, but y now is y naught, which is going to be 0, okay, plus 4z, again, z is z naught, which is going to be 0, so that's plus 4 times 0. So you simply have this. So this simply implies that your first iteration value for x1 is going to be equal to, so I'm going to punch everything together just to save time. Do well to punch along with me. But keeping in mind, 2 times 0 is off, that's 0. 4 times 0 is also off, that's 0. So I simply have 34 divided by 40. Okay. So 34 divides 40 simply gives us 0.85. So I have my first iteration value for x to be 0.85. So you keep this aside. Okay, so you keep this value aside. All right. Now we do the same thing now for y, and this is the equation for y being equation 5, being equation 5. So it means the first value of y, y1 is going to be equal to, you simply plug the initial guesses. So wherever you see x now in this equation, it replaces s naught, and s naught is 0. Similarly, wherever you see z, it replaces z naught, and z naught is also 0. So I simply have 1 over 40 once more. This is 1 divides 40, multiplying through now by, I have negative 36 there. So by negative 36 minus, I have 2x here, I have 6x here, and x is 0, so that's simply 6 multiply 0. That's simply 6 multiply 0 plus 2z, again z is 0, so that's simply plus 2 times 0, and you have this. So this simply implies that y1 is going to now be equal to, so once more, 6 times 0 is 0, and 2 times 0 is 0, so I'm simply left with negative 36 divided by 40. So you find negative 36 divides 40, that simply gives us negative 0.9. So y1 is simply negative 0.9. You keep this value aside. Okay. Next we solve for z. Okay. So next we solve for z, and next we solve for z. Z is now going to be equal to, this becomes z1, and z1 is going to be equal to, from the equation we have 1 over 40. So once again, 1 divides 40, multiplying through by, I have here 50. So multiplying through by 50, okay, minus 4x, but x represents x naught. where x naught is 0, which is initial guess. Again, y represents y naught, where y naught is 0. So that simply becomes minus 4 times 0. So I have minus 4 times 0, okay, plus 6 times 0, plus 6 times 0, and you simply have this. So this simply implies that z1 is now going to be equal to, so let's obtain that result. Again, 4 times 0 is 0, 6 times 0 is also 0. So you simply have 50 divided by 40 left there. So 50 divides 40. This simply gives us 1.25. So we have the first iteration value of z to be 1.25. Okay, so you keep this equation or this result. Now, having found these values now, all we need to do now is simply you plug these values into these equations again to carry out your second iteration. So in order to obtain x2, which is from the second iteration, it means now that from this equation, y becomes y1, which is the result to obtain here for y1, and z becomes z1, which is the result to obtain here for z1. So we are simply going to be plugging these values back into this equation to carry out our further iteration. So after the first iteration, you carry out the second iteration. So we carry on now with the second iteration, not forgetting these are the values we obtained from the previous iteration. Now for the second iteration, we iterate the value of x. So x now becomes x2 for the second iteration. So x2 is going to be equal to, we are still maintaining this equation. So that becomes 1 all over 40 multiplying now by, I have here 34, okay, minus 2y, y now becomes y1, so minus 2y1, y1 now has a value of negative 0.9, so negative 0.9, okay, plus 4z, z now becomes z1, so that is simply plus 4 z1 itself. We had z here to be equal to 1.25, so that becomes plus 4 times 1.25, and we simply have this. So let's see what we are going to obtain. Please, I'm going to be punching everything together just to save time. Do well to punch along with me to avoid calculation errors. So when you punch everything together, you have x2 to be equal to 1.02. You keep that aside. Now you iterate for y, that's y2. You're going to have y2 to be equal to, once again, 1 all over 40. So you have 1 over 40 multiplying through by, I have here negative 36. So minus 36. Again, I have here negative 6x. So minus 6. Now, x here becomes x1, which are the previous values obtained from the previous iterations. So x1 here is 0.85. So it becomes 6 times 0.85. Again, I have here plus 2z. So multiply by plus 2 times z becomes z1 once more, which is 1.25. So 2 times 1.25, and you have this. So this implies that I'm going to be having y2 to be equal to, so I'm going to be punching all together once again. All right, so upon evaluation, I have y2 to be equal to negative 0.965. Okay, so having found second iteration for y, we move now to solving for z. So we find the second iteration for z, which is z2. This is going to be equal to, once again, 1 all over 40. So 1 divides 40, now multiply by, I have 50 here, multiply by 50, okay. Now I have minus 4x. So you have minus 4x, that becomes x1, and x1 is 0.85. So minus 4 times 0.85, okay. Then I have plus 6y, y there becomes y1, which is plus 6 times y1, we obtain negative 0.9. So 6 times negative 0.9. Okay, so I'm punching everything all together. This implies that z2 is going to be equal to, all right, so upon final evaluation, I have z2 to be equal to 1.03. Okay, so you don't really compare from now. You compare after at least 4 to 5 iterations. That's when you start comparing, because that's when you believe that the values will some sort of start converging, right? But at these initial stages, you don't expect them to start converging. So this will now take us to the third iteration. So in the third iteration, all we are doing now is plugging these previous values now obtained for x2 into these equations. So in the third iteration, this y here becomes y2 and z here becomes z2, x here becomes x2, and so on. Okay, so we simply plug in the previous values of the iteration obtained into the current value of iteration we are doing. All right, so we'll go now to the third iteration. So once more, for the third iteration, x now becomes x3. X3 is now going to be equal to, from the equation, I have 1 over 40. So this is 1 divides 40 multiplied by, I have here 34. So multiply by 34 minus, I have here minus 2y. So minus 2, y now becomes y2, and y2 here we had negative 0.965. So minus 2 times negative 0.965. Again, I have plus 4z. So that becomes plus 4z, there becomes z2, and z2 gave us 1.03. So plus 4 times 1.03. Okay, so let's see what we are going to have. And x3 is going to be equal to, let's punch everything together. So upon final evaluation, we have x3 to be equal to 0.9578 approximately. So we are choosing 4 decimal places. Okay, now we solve for y3. So y3 is going to be equal to, so the equation for y is simply again 1 over 40. So we have 1 divides 40 multiplying by, I have here negative 36. So minus 36. Again, I have minus 6x. X now becomes x2 since we're on the third iteration. So this is minus 6 times x2. X2 itself gave us 1.02. So 6 times 1.02. Okay. Then I have plus 2z. So you simply have plus 2z. Z now becomes z2. And z2 gave us 1.03. So plus 2 times 1.03. So let's see what this is going to give us. This simply implies that y3 is going to be equal to, so upon evaluation, we have y3 to be equal to negative 1.0015. Now we carry on with the third iteration for z, that is z3, and this is going to be equal to, now the equation for z is simply 1 over 40. So you have 1 divides 40. Now multiplying, I have 50 here. Multiply by 50 minus 6 minus 4x. So I have minus 4x. X now becomes x2, and x2 is 1.02. Okay, then I have plus 6y. So plus 6y is y2, and y2 simply gave us negative 0.965. So plus 6 times negative 0.965. So let's see what this gives us. This simply implies that z3 is going to be equal to, let's punch everything together. So upon final evaluation, we have the value of z3 to be equal to 1.0033 approximately. Okay, so we carry on now with the fourth iteration. Like I said, you start comparing when you carried out at least up to 4 iterations. That's when you start comparing the values of x, y, and z. Okay, all right, so we carry on now with the fourth iteration. So for the fourth iteration now, in this equation, we are now going to be plugging in the value of the third iteration or the previous iterations obtained. So y now becomes y3 and z becomes z3. X becomes x3, y becomes y3, and so on. So for x, we have x4. X4 is going to be equal to, from the equation, 1 over 40. So you have 1 divides 40 multiplying by, I have here 34. So multiply by 34, and I have here negative 2y minus 2 y itself becomes y3, and we obtain y3 to be equal to negative 1.0015. So you have minus 1.0015. Again, you have here plus 4z. So this is now plus 4, and z becomes z3, and we obtain z3 here to be 1.0033 approximately, and we obtain z3 here to be 1.0033. So plus 4 times 1.0033. So let's see what we are going to obtain for x3. Okay. So upon final evaluation, we had x4 to be equal to 1.0004 in 4 decimal places. Okay. Now we carry on for y4. So we carry out the fourth iteration of y. y4 is going to be equal to, once again from the equation, you have 1 over 40. So 1 divides 40 times, we have here negative 36 minus 36 minus, we have minus 6x, x now becomes x3. So this is minus 6x3, and we have the value of x3 to be equal to 0.9578. So in place of x there, you plug in 0.9578. Okay. Then you have plus 2z, and z there is z3, so this is plus 2. The value of z3 obtained is 1.0033. So 2 times 1.0033. Okay, so this simply implies that we are going to have our y4 to be equal to, let's punch everything together. All right, so upon final evaluation for y4, we had y4 to be equal to negative 0.9935 approximately. So we actually solve for z4 at once and plugging in the values into the equation. This is for z4. So you still have 1 over 40 multiplied by 50. So this is 1 over 40 multiplied 50. So you have minus 4x. X now is x3. So that becomes minus 4 times the value of x3, which is 0.9578. Okay. Then you have plus 6y. Y now becomes y3. That is plus 6. Y3 now is negative 1.0015. So upon final evaluation here as well, we have z3, we have z4 to be equal to 1.0040 approximately. So you've done up to 4 iterations. Now let's try to compare with the previous result and see if they've converged. Okay, so in the previous result, we have for x 0.9578, that's x3. But in this current iteration, we have x4 to be equal to 1.0004, which means x has not converged yet. So we still have to carry on with the next iteration. Similarly for y, in the previous result, we had y to be negative 1.0015, but in this result, we're having y to be negative 0.9935, which means, again, y has not converged. So which means we have to further the iteration. Same thing applies to for z. In the previous value of z, we have z3 to be equal to 1.0033. In the current value, we're having 1.0040, which means it hasn't converged. So we carry on with the fifth iteration. Okay. All right, so we carry on now with the fifth iteration. So in the fifth iteration, now we are plugging in the values of the previous iteration into this equation. So y here becomes y4, and z here becomes z4, and so on. So let's iterate for x. This becomes x5. x5 is going to be equal to, from the equation, we'll have 1 over 40. Okay, 1 over 40 multiplying now by, we have here 34. Multiply by 34, okay, minus 2y. So minus 2 times y now becomes y4, and y4 is negative 0.9935. So times negative 0.9935. Again, we have here plus 4z. Okay, so plus 4z now becomes z4, and z4 itself is 1.0040. So this is simply 1.004. Okay, so let's see what x5 will give us. All right, so upon final evaluation, we have x5 to be equal to 1.0001. And if you compare this result with the previous result of x5 and x4, x4 is 1.0004, which means correct to 3 decimal places, x4 has actually converged. So which means we have found the root of the equation. X4 has actually converged, and correct to 3 decimal place, you have 1.000, 1.000. So which means you can key your iteration after the 5th iteration. But let's proceed and see if both y and z are also going to converge. So that will bring us now to y5. So y5 is going to be equal to, once again, 1 over 40. So you have 1 divides 40, multiply now by, I have here negative 36 minus 36. Okay, I have here minus 6x. So minus 6x now becomes x4, which is the previous value obtained in the previous iteration, and that is 1.0004. So 6 times 1.0004. Again, I have plus 2z. Z now becomes z4. So this is going to be plus 2 times z4. We obtain z4 to be 1.0040. So this is 2 times 1.004. So let's see what this gives us. This implies y5 is going to be equal to, let's point everything together. Okay, so upon final evaluation, we have y5 to be equal to negative 0.9999. And if you compare this with the previous result, y4, we have negative 0.9935. So you see that y4 and y5 actually converged after 2 decimal place. So which means y has also converged. Now let's try finally for z5. So z5 is going to be equal to, once again, 1 divides 40. So we have 1 all over 40 multiplying by, here we have 50. Okay, next we have minus 4x. X now becomes x4. That is minus 4 times x4 itself is 1.0004. Okay, then I have plus 6y. Y is y4. So plus 6 y4, and y4 is actually negative 0.9935, negative 0.9935. So let's see what we are going to have for z5. Okay, all right, so upon final evaluation, we have z4 to be approximately 1.0009, and if you compare with the previous value of z obtained, we have 1.0040. So which means correct to 2 decimal place, z4 has also converged. So in general, all the equations actually converged correct to 2 decimal place. X4, x5, you can also call that 2 decimal place. Y4, y5, same thing, and z4, z5. All right, guys, so this simply implies that the root of that equation includes x to be equal to 1, y to be equal to negative 1. Of course, you can approximate y here, and that simply gives you negative 1. That's if you simply round off, right? And z to be equal to also approximately 1. So you can go ahead and plug these values into the given equation and see if you're going to have the same result. For instance, you've got x here as 1. So x is 1. Then go ahead and plug in the value of y as negative 1 here. Plug in the value of z as 1. Compute all of this if you're going to have 1 equals 1. If you do, then it means you're right. If you don't, then it means we are wrong. But I'm sure that we are very much correct. All right, guys, so that's how to employ the Jacobi's iteration method to solve systems of equation. In the next video, we are going to be looking at eigenvalues and eigenvectors in numerical methods. I'm sure you want to be a part of that video, so do well to hit the subscribe button right now and turn on your notification bell so you don't miss out on that video when it drops. Please do well to like this video, comment nicely, share to your friends, and I will see you in the next video. Thanks.